In this video, we're going to cover basic concepts in thermal physics, starting with temperature and heat. Within the scope of this video, we can describe temperature as the degree of hotness or coldness of a body. Heat is a form of energy which is transferred from one body to another as a result of a difference in temperature. And heat energy will naturally move from a body having a higher temperature to a body with a lower temperature. Temperature and heat are both scalar quantities, and temperature is measured in degrees Celsius or degrees Fahrenheit or Kelvin, which is the absolute temperature scale. Heat, which is a form of energy, is measured in the same unit as energy, the joule. Heat transfer occurs by three different means. The first is conduction. Conduction is the transfer of heat through direct physical contact. In conduction, heat is transmitted through collisions between neighboring atoms or molecules. For a solid object with uniform cross-sectional area, the rate at which heat is transferred from one point to another within this object is directly proportional to the cross-sectional area and the negative of the temperature gradient between these 2 points. The temperature gradient is the increase or decrease in the temperature per unit length, and the negative sign makes sense because a negative gradient means the temperature reduces as we move further along the object, so the heat flows from the hotter side to the colder side, which is our positive heat flow. The constant for this variation is called the thermal conductivity of the material and is often denoted by the letter K. Each physical material has a specific value for its thermal conductivity. The second means of heat transfer is convection, and this is the transfer of heat by mass motion of a fluid from one region of space to another. Cooling systems in many machines use convection to prevent heating up by passing a fluid, commonly called a coolant, through the heated region, where it absorbs heat and is then transferred to a cooler region, usually the atmosphere, where it can give off the excess heat. The last means of heat transfer, radiation, is the transfer of heat by electromagnetic waves. Unlike conduction and convection, radiation requires no medium. An example of radiation is the transfer of heat from the sun to the earth. Most substances expand when heated and contract when cooled. The rate of expansion or contraction, however, depends on the substance. A solid object with a uniform cross-sectional area, for example, will increase in length when heated. This is called linear expansion, and it has been experimentally observed that the change in length of the object, to a good approximation, is directly proportional to the change in temperature, delta T. The change in length is also directly proportional to the original length of the object. We can write this proportionality as an equation. The proportionality constant is called the coefficient of linear expansion or linear expansivity of the material and has the unit inverse degree Celsius. The change in volume of a material which undergoes temperature change can also be expressed by a similar equation to our equation of linear expansion. In this equation, delta V is the change in the object's volume, delta T is the change in the temperature, V0 is the initial volume, and beta is the coefficient of volume expansion or volume expansivity of the object. When we study gases, the three most important parameters or quantities which are essential are volume, pressure, and temperature. For a gas, these three quantities are interdependent on one another, and it is often useful to obtain relations between them. For a given quantity of a gas, it is found experimentally that the volume of the gas is inversely proportional to the absolute pressure applied to it when its temperature is kept constant. This relation is known as Boyle's law. From Boyle's law, we can state that the product of pressure and volume of a gas will remain constant provided the temperature does not change. Another gas law, called Charles' law, expresses the relationship between the volume and the absolute temperature of a gas at constant pressure, and it states that the volume of a fixed quantity of gas is directly proportional to the absolute temperature when the pressure is kept constant. A third gas law, known as Gay-Lussac's law, states that at constant volume, the absolute pressure of a fixed quantity of a gas is directly proportional to the absolute temperature. Our three gas laws can be combined into a single, more general relation. The product of pressure and volume also depends on the quantity of gas present, so it's also proportional to the mass of the gas. We can make this into an equation by introducing a constant of proportionality. For this relation, the constant varies depending on whichever gas is being observed. However, it has been observed that the constant of proportionality turns out to be the same for all gases if we use the number of moles instead of mass. So here, N represents the number of moles and R is called the universal gas constant. The universal gas constant in SI units has a value of 8.314 joules per mole kilograms, and our equation is called the ideal gas equation.